basically, the notion is we're covering the screen with borderless windows. We have an OpenGL window here that's currently not showing off anything, but there's going to be a lot going on in there. This is an SDL renderer inside of another borderless window, and what that's going to look like is basically buttons. It's going to be buttons to interact with the OpenGL environment over here. The reason I'm doing that is I have way easier utilities for font rendering in SDL using SDL TTF, which is a library that makes that incredibly simple. But yeah, so basically this is all it does right now. It'll launch and do a little test of my font routine, which is then you hit escape and it quits. So I've got it pull some information from my computer when it starts. Tells it where it starts from, what platform you're on, your screen resolution, which becomes important when I'm covering the screen with everything. See, they like this is based on thirds, so we've got 1/3 of the width and then 2/3 of the width. Then we've got 2/3 of the height and then 1/3 of the height. And obviously this one's the full height. But and you saw that red bar across the bottom. That's because my the way I'm doing splash screen is broken because of some other stuff I was doing. Before I had an explicitly sized window that was the same size as those images for the splash stuff, but that I'm going to move away from that so that it's more flexible and it can run on other machines. It's not locked to a hard-coded resolution. Another cool thing I didn't know about, you get battery information from SDL. It gives you like a state. It's an enum that gives you a state. Tells you how many seconds are remaining if it's in a draining state, and it tells you like a percentage. So there's like fully charged and plugged in, charging and plugged in, like plugged in and not fully charged. I believe this is something for like a desktop kind of situation. Then this one is on battery, so this is just your standard not plugged in operation. And I'm not 100% sure what that means, so we're just gonna kind of just report that it's in an undetermined state. Anyway, so this levels deep thing, my notion is that basically within that button window, the OpenGL button window, where I've got the text rendering, is that I'm going to stack up windows, not windows, but I'm going to stack up, well, that's an interesting idea. What if I did treat them as windows, because then they'd be separate OpenGL, or not OpenGL, they'd be separate SDL entities. Aesthetic of it kind of being staggered out like sheets of paper or like some sort executables. One was the client, one was the server. I just had them compiled separately, and I ran them separately. So you run the server executable in one window, and you get the client executable in the other window. So I don't know if it's acting weird because I'm streaming at the same time, but right. So it would use the Linux networking like pull and read and write commands. I had an operating systems class where we kind of dug into that kind of stuff. But the real takeaway here is these the way that I had done these menus, kind of in a stacked up sort of way. It may be better not to slide them to the side and just have them, or maybe just have that be like 1 or 2 pixels to the side, so that it's not like crazy. That may actually be a better idea, because if you look at kind of the proportions of how we've got it drawn, it's like it would be equivalent, really like a 1-to-1 sort of slope there. And I don't know if that's necessarily what you want to do. But this is kind of a cool way this project worked. It kind of gave you more information than, well, so it's going to be a different situation with the SDL one. We'll be doing a lot of the same things. I'm going to have to dig through this code a little bit, because I want to try and figure out what menu options I was going to include. But the idea that like you have this main menu, and we'll go back to where I was at the main menu. Right, so you're at the main menu. Okay, then I want to draw, so I wrote in draw. Right, and then it brings me to the draw menu. Right, so when you put in draw, then you can go to the draw menu. Okay, I put in sphere, then I go to the sphere menu, and now I have all these different things, so I can input these letters to change these values, and this is all done with like C in, C out, kind of just real basic IO. And a boolean for draw and a boolean for mask. Basically, what this is a voxel editor, but we're treating it like they're pixels, very much like GIMP or MS Paint, more GIMP than MS Paint, because I'm doing this whole masking thing that I think is kind of interesting. Basically, there's a set of primitives that you can draw with. That's, for example, here we've got a sphere, and that's defined by a center point, X, Y, and Z, and then a radius. You have 16-bit color fill. Then let's see. Yeah, so if mask is true, that area inside of that sphere will be masked. If draw is true, the area inside that sphere will all be drawn over, unless those are already masked. So basically, this masking thing is actually really cool, and the way I've got it set up for the primitives is kind of cool too, because you can set draw to false, and you can set mask to true, and then you're just masking everything inside of that sphere. You're not actually drawing that sphere anymore. Right, so the way I have it structured here is, you configure your numbers, then you type in send. So I'll just step through this a little bit. So, you see you're putting in values there. mask value for every pixel. You can unmask all cells. You can unmask all zero cells, or all non-zero cells. That's gonna need to change because that's not really well defined. That's back when I was using a palette-based thing where every voxel basically just had one number associated with it. But you see this structure that has like a couple levels of menus. Then you have like different options, and as you pick the different options and stuff in the different sub-menus, then you see like, alright, so time, you basically send a message to the server to report the time. Display, the server shows you the block. And what that is that's the voxel data. Get to where that's actually being done. Oh, shit, no. So, yeah, this is a 256 by 256 by 256 block, so it's not practical to show it on the command line. It should just be a matter of taking, let's check this one out. So, yeah, this client server model was kind of cool, and it provided some level of interactivity with the software, which I think is cool. But so here's a much smaller dimension block that's practical to display. So it would basically show you, here's like X, Y, Z kind of idea, and we've got everything listed out in hexadecimal. It looks a little weird like that, but so yeah, you tell it, all right, I want to know the time. If you want to know the time, it'll tell you the time. So that's not super useful in the grand scheme. Damn, this thing is not. It doesn't like when you stream and try and watch YouTube videos at the same time. Go figure. No, but so basically, drawing noise patterns is done with Perlin noise into the block there, and then you see how it has changed. There's some value that I told it to fill in the noise with if there's some threshold. Basically, so there's a fill. What are you going to fill it with? That's a number. In this case, this is an older version. Scale is how big the lobes of the Perlin noise are. This is basically how the XYZ values are scaled. And then there's a threshold, which is basically when you look at the noise function, the number you get back. If it's above or below a certain thing, then you're going to be able to so if it's a positive value, I think it's less than, and if it's a negative value, I think it's greater than. That's the way I structured it. It's not super intuitive, but it kind of it lets you get the zero side and also the one side of that noise if you want to do different patterns and stuff. Or a pattern that's sort of like, so here's the low side, and then the high side would be everything else, basically, right? So everything above 0.5 is what didn't change in this particular fill operation here. So yeah, then showing off how I can draw a sphere into that. With the sphere inside. Oh wait, I actually showed off some masking in here too, it looks like. So I must have masked something and then drawn a sphere. In any event, it didn't draw over some of them, which, that's that masking in play, is it's the ability to retain the value when it would be overwritten by a subsequent draw command, basically. That's the simplest way to quantify that, I think. But so my notion, well, now that I'm looking at this doesn't really make that much sense to try and do it in terms of levels deep. I think it's because I'm going to be putting together an enum that has all the different menus. So this is like the initialization. It's like where you start. Your draw menu is like, some value of 1. There's only a finite number of different menu states that we need to support. So it's like, you can count those off and you can have labels for each of them. But I'm thinking maybe we just don't take an argument there, and then we'll just OR a set of them together. So like draw menu would be part of this set of states that are 1 level deep. Main menu being in the set of the only one in the set of menu options that are 0 levels deep. And then anything below draw would be 2 levels deep. And if you were to go another layer beyond that, that'd be 3 levels deep. I think that's going to be a much more logical way to go about this. I don't think that. I really don't think this, the way I'm doing it right now is a good idea. So it's just going to look at the current state of the menu. Because I'm keeping one of those as a to keep track of. So let's think about this. I think what the best way to go about doing all this would be. Turn down the music a touch. Oh wait, no, it's all coming through the Jag stream, so that's not gonna work. Yeah, I'm having to do some workarounds. I was kind of beating my head against trying to get just get Jag to go through to OBS. That's a whole thing. It gets very complicated very fast. So that's not the right way to do that, but just that's the way we're doing it. So yeah, so we had some like a utilities menu, and then there was all these different config menus for the different noise, points, spheres, ellipsoids, which are extended spheres, cylinders, tubes, which are cylinders with a cylinder cut out of the middle, but you get away without doing two primitives. Cuboids, which was a really flexible primitive. It's just a pain in the ass to use. It's 8 points in space that it's hard to define them. But alright, the simplest case would be a cube, where it's just the corners of a cube. But you think about it, if you're just defining those corner points and the way that I'm determining whether or not you're inside that shape is by considering each face of it as a plane, well, then the organization of those points matters, which makes it a huge pain in the ass to try and organize, because you gotta look at a graph, like a chart thing every single time. But having the faces based on planes, okay, well, there's other limitations too, because those the two triangles in the face may not be in plane with each other if you're defining those 4 points out of a plane, right? But as long as the 4 points defining any given face are in a plane, then you're set. And then you can stretch it, so it could be like a rectangular prism, and you can also warp it, so it could be like a trapezoidal prism, or is that right? Gotta review my basic geometry. Yeah, so trapezoidal sort of. You can see those types of warping. So when the faces aren't at right angles to one another, that primitive still supports that type of shape. And the isosahedron, that was a whole thing. And this was actually, it looks like it was before I was doing triangles. Or it may have been when I was doing triangles in a really stupid way. Might want to look at the Veraldo code in here. Because I don't remember what I was doing at this point in time. But yeah, this is how I implemented those stacked menus. It's literally just, it's straight, written out exactly as it appears in the command line. And then you gotta, worry about, like, I have to use all these, like, width specifiers for the different values and things to keep everything in range. And just, this got really tedious, and a lot of finagling for not a lot of value. I guess everything on the client side really is just generating a message to send to the server. So the relevant pieces here are going to be pulling out like things like this. So we have a utilities menu, and then these. I don't know if this is going to be the actual list. I'm going to need to spend some more time thinking about that. But at least this much is accurate. They'll all be happening down there. As we come up with more of those, that'll be masking operations, and I actually have quite a few different masking operations. I want to do like a mask by color because I'm not doing a palette-based system anymore. It's an explicit specification of color for every voxel, RGBA and 16-bit values. So I've got a lot of precision to work with, and the only reason that I'm like able to do that is because one of the machines that I run this on has a Radeon 7 graphics card in it, and that thing has so much memory bandwidth it is insane. And I can get away with using enormous textures like that. So that's kind of like down the road a little bit, but I'm prototyping this on a ThinkPad. It's just it has an integrated GPU. It's not anything to write home about, and it won't really run anything crazy. I have run into some limitations based on the Mesa driver that it runs because we're not using any sort of like NVIDIA driver or anything like that. One of the main things was for my final project. For this graphics class that I took last semester, that was it was a real-time cellular automata in a three-dimensional space. So it's voxels that did wire world, and I can't really do videos, but I can at least pull up an image of what it looked like. It was actually really impressive the way it turned out. This is it's a classic cellular automata that it's been around for years and years and years. But basically, this would run in real time. Basically, I can generate this voxel thing. I have a display routine that raycasts into the volume, and it has just these square representations of every voxel because it's a cube as part of an array. So there's an integer like index associated with it. So when you're tracing that ray out there in terms of floating point numbers, it's passing through a whole bunch of little cubes, basically, if you wanted to quantize that space. And that's basically what's happening here with the voxels. And so this is one little corner of a 256 by 256 by 512 voxel block. Every single voxel had a compute shader invocation run for it, which is insane. That's like 16 million invocations. Well, no, what the hell is that? It's not. It's more than that. It's gotta love that. That's 33.5 million cells updating every frame. The way that damn, I wish I could play this back. But basically, the way it worked was I created 33 million invocations of the shader. It was a vertex shader being used as a compute shader. And that's only because that was only because I didn't really know how to use compute shaders. That's what that was about. But the part that was like that made it difficult to run on the laptop was that there was a variable that was max vertex shader image uniforms equals 0. So basically it means that on the Mesa driver they don't support image uniform variables in a vertex shader, but they do support it in compute shaders, which means that we're good there, right? It's not an issue anymore. It's just yeah, yeah, if we do it in a compute shader, we've got a lot of options open up. I think one of the other big things is using 16-bit textures. Is I got a lot of fucking bits to work with. I can use those as flags. I can use them to represent the masking. I can use like 16 bits of alpha. I have run into limitations with 8 bits of alpha. I have actually had legitimate issues with a value that only has that kind of range. Like the gradations between the numbers are not fine enough. Or at least they weren't for what I was trying to do at the time. Really wish I could, show this off. Running in real time, like it does. But I guess I'll just have to take my word for it. So it kind of, Wire World goes crazy when you get into wider paths because it's really only designed for, it only really works for like traces that are 1 voxel wide. So there's cool patterns like this. This is actually a little diode in Wire World. So that's something that only flows one way. So it'll only let one of these little pulses go through this way. It won't let it go back through the other way. Yeah, so that's the whole thing. And I'll get that running again at some point. Well, I can get it running easily. It's just a matter of it's got to be on my other computer in order to do the animated part of it. But that's where I'm at, is using the compute shaders to do the different draw functions, to do the different mask functions, and I want to support like an undo thing. I'm going to keep another copy of those images as kind of like a backup. It plays really well with the structure of what I was doing before, because I had to keep 2 copies of that image, because if you think about it, there's coherency issues where if you read from the same image and write back to the same image, you don't necessarily, because cellular automata looks at the neighborhood, you don't know what order everything's going to complete in, and you're going to end up with a real shit show in terms of just, it's just a race condition times 33 million. So it just doesn't make sense at all. The way I did it was basically, you got 1 image uniform in texture unit 0, you got 1 image uniform in texture unit 1. Okay. Your shader just says take everything from unit 0, update it, put it in 1. Okay. Then your fragment shader says, all right, raycast volume 1, or texture unit 1. And then CPU side, when that frame is finished, I swap them out. So 1 becomes 0, 0 becomes 1. by the updated values from 0. And you see that's a sustainable way to do that because it's not stepping on its own toes anymore. But what I'm saying is basically built into that is almost a little bit of an undo capability. So, if you wanted to roll back to that previous state, you wanted to undo whatever you did in the last operation, you would just go back to what that previous state was. You would just not swap, basically. Or rather, swap back. So that part's not super complicated. It's just, it's a lot of parts, and I think it's going to be a little while before I get to the point where I'm doing fancy shit with compute shaders. It's right now, I got a couple other things I want to try and do with it, namely lighting, real-time lighting, because I've done not real-time lighting, lighting which takes like 3 minutes per frame. That's not at all practical. That's like, it doesn't work. Where's it at? Let's pull one of these up. Yeah. So, the directional lighting was basically the same way that I do the display function, where for every pixel I trace a ray out into the scene to see if it hits anything. I'm doing that same thing, but as that ray goes through, instead of doing any sort of like alpha blending kind of operation, I'm actually just subtracting from some intensity value. So that light gets less intense as it passes through more opaque objects. So you see the sun shafts that sort of appear behind the solid objects, and they're extended shadows, basically, because there's a plane that's been passed through, and as parts of that plane hit more solid objects, those parts of that, all the rays that are associated with that part of that plane, become dimmer. Right? It's a lot like the concept of a shadow map. I actually learned about the shadow map concept after I did this, but very, very similar concept. This did the same thing, but it animated an icosahedron in the middle, and then recomputed the lighting at each update. So you see dynamic shadows here. What's more, you also have, these are semi-transparent faces, so you can see areas where there's been partial dimming of that light. Like it's not a full shadow, but it's a good chunk of a shadow. Damn, I wish that message didn't, just kind of sit over top of everything, but in any event, that's the basic gist of it. To get that general notion, what I want to do is I want to do that in real time. I want to have that so that it's able to execute on like a per frame basis, the same way that I had the Wire World simulation running. So there's a lot of work to do, a lot of different pieces. I want to take all the best ideas from just something that people can understand more than like a scripting-based interface, which is something I've used before, or a like the command line interactive client-server-based interaction. Which, I mean, as you saw in that other video, that does work as a concept. It's just I don't know that that's necessarily